Okay guys, this is year 1 of IB. This is section 3D. I have a couple things circled here, but before we get to that, we're talking about the measures of dispersion today. And basically that just means how far apart is your data? How spread out is it? And the easiest one that I guess we've always talked about in the past would be the range. The range, remember, is the highest number minus the lowest number. Basically, how many values are in between, or not the values, I guess, not how many of them, but how far apart are the largest and smallest values. The second one, actually, and you guys should be kind of happy about this, the second one is called standard deviation. And standard deviation is actually something that we're not going to find by hand. And so we will use our calculators, and you guys, when we did the single variable stats under the stats button, it was already there. So all you have to do then is just look for that little symbol like we have here of rho, and you will be given the standard deviation. Guys, standard deviation is considered what they sometimes call as a root mean squared deviation. And there is a formula there. That formula, guys, it looks scary, but it really is not scary. You need to know the average and the number of terms in a problem set. And so to find the mean, or the standard deviation, sorry, is 1 over n. N will stand for the number of terms in that data set. X bar here, the little bar over the top, that is mean. So you guys remember that from the last lesson or two. And then x sub I is actually the term. So the first term minus the average, the second term minus the average, third term minus the average. You square each one of those, and then remember this is the summation, so we're adding them all up. You're going to divide by the number of numbers that are in the set, and then the last thing you do is take the square root. We will use technology to find this. Now if you go to the next page here, this is an investigation. They want us to actually find the standard deviations and what they're called the means of the two data sets here, the girls' scores and the boys' scores. So what they're going to do in this investigation is they take you through here and say, hey, look at the girls' scores and then minus the average or the mean. And so you would put those in this column. You do the same thing for the boys' scores. I'm not going to take the time to do this because I think it's fairly straightforward. If you want to follow it, do it, please. And then what they want to do at the very end here is they'll just square those results that you found in these columns. And at the end, you add them all up. And then it says, lastly, you take the square root of those values. Obviously, I think right before, I think they forgot the fact that you still have to divide by, I think there was 10 total scores. Take that number, divide it by 10, take the square root, you will have standard deviation. So it's very doable, but if you have a large set of numbers, you're not going to want to do that. And so it just basically says on the bottom here, what does that really standard deviation represent? It's how far from the average, on average, is your data spread out, or from the average. So this is the answers to the questions from example 3 earlier in the book. They wanted to know for each of the 3 data sets in example 3, find the standard deviation and compare them. So standard deviation are the first examples. They are these ones. So if you remember back to the ice cream and the dice thrown and the weights of things. So one of these is just, single data point, great, no frequencies. Now in part B you have a frequency. So we had to put those on our calculators. We had to go to stats, we had to make some lists. We went to single variable stats. So make sure that you use your single variable stats. You make sure you use a frequency table if there are multiples of each other, because that obviously takes our data from really large table down to a little bit smaller table. And then don't forget that when we went to tables like this, that you went down the middle. So 2.5, 3.5, 4.5, things like that. So again, the cool thing about it is that standard deviation is already part of that list. And actually a lot of the things that we're talking about today in this lesson are already part of that list. So when you go to that list, put your data in, go to single variable stats, you will see that they will have the row symbol, standard deviation, that looks like that. And it should say for that first group a 30.8. And what would that actually mean? That means if you have a standard deviation of 30.8, that means your data is really spread out. That means there's really large gaps between all of your data. If you do part B, it's a 2.8. So if you had to say, hey, who's got a closer data, you're going to say that 2.8 standard deviation is a lot better than a 30.8. And so that's how you're going to start to do those things. Now, variance, on the other hand, is actually pretty easy to figure out. It's just take the square of the standard deviation. So if you want to know the variance of something, just square the standard deviation. So it's not directly as part of that list on the single variable stats, but it is there. You just have to square the standard deviation. And so they use that for different items as well. Now, the last part here on this slide is called the interquartile range. The interquartile range, guys, is the upper quartile minus the lower quartile. You're probably thinking, wait a minute, I think I've heard of this before. Guys, if we've ever made a box and whisker plot, you have found upper, lower medians, upper quartiles. We call those medians because you have a group of data that has a max and a min. You find the middle, which is your median, and then you would find your upper median, and then you would find your lower median. AKA upper median and lower median is the upper quartile, the lower quartile. So it's basically cutting your data in half by finding the middle, and then cutting the top half in half and the lower half in half. Now, biggest thing, guys, when you're finding the upper and lower median, do not include the median even if it's part of the original data set. Because remember, sometimes to find the median, you get down to two numbers, you have to take the average. If the median is, say, one of your actual data values, you don't count it when you're trying to find the lower and the upper medians. Okay? So that's just kind of how you're going to play that. But here's a really cool thing I'll let you know. That upper and lower medians just represents 25%, medians at 50%, and your upper. So this is 25%, 50%, and 75%. So you could technically take the number of numbers in your data set and multiply it by 0.25. It'll tell you how many to count up. 50%, how many to count up from the bottom. Make sure you put them in order. That is the best way to do that. The other cool thing is if you are already doing the single variable stats, it is already on your calculator. Just start paging down just a little bit more in your menu, and you will actually see that it'll say Q1, Q2, I think, or median, Q3. And it'll also give you the max and min. So you actually find all 5 numbers that you would need to make a box and whisker plot, which is absolutely fantastic. And so that's what this whole graph is kind of going through here on the bottom, is the fact that, hey, if I had this group of numbers, hey, if I found out that there were, I'm not sure how many numbers were in here. I didn't count it. But say that there were 20 numbers. So I can take 20, multiply that by 50%, and it should be 10 numbers in. Actually, in this case, it would be 10 and 10 both ways, and then therefore the middle number is in the middle. And then I would not include this 62, and then I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So 11, divide that by 2, and I'd be at 5.5. So 1, 2, 3, 4, 5, and then the next number is in the middle, because it has to go both ways. There's 11. So 5 and 5 on each side, 6th number is in the middle. So that's one way to figure that out, and that's what they're trying to show you there, that you don't have to use a calculator to do this. You can multiply it by 0.25, 0.5, and 0.75. The next slide here, they actually want you to go back to that example 3. You guys can go back in the video if you want. Again, we're not going to actually sit down and do the numbers because we already did on our calculators, or showed last time, that the variance, or not the variance, the standard deviation for problem number 1 was 30.838, la-ti-da-ti-da. So the variance is just square it. Now it says the variance to do 2 dp, 2 decimal places, so that's why they put 950.98. They want to know the range. They took the top number minus the bottom number, got 92, and then the interquartile range. On your calculator, 188 was the top median, upper median, and 150 was the lower median. Subtract them, you have it. And they did that for all 3 problems. Again, I don't think this is going to be very much of a struggle because you're going to put the data on your calculator and it gives you everything you need. And the last investigation, which you guys could do on your own, but we'll just talk about what comes out of it. Guys, it says that the mean is the set of numbers is x bar, right? And the standard deviation is the row with a little x because it's in terms of x. But if you add k or to subtract k from each of the numbers, then obviously the average will go up by or down by a value of k. The cool thing about it is standard deviation doesn't change because you're not changing the gap between all of your numbers. But if you multiply each number by k, then the average is multiplied by k. So your average will go up by k. But the standard deviation will also change because a gap of 2 gets multiplied by k, so it's actually k times larger. That means the standard deviation will also increase by a multiple of k. So your homework, here are some problems here for you to do, and then it goes off onto 5 through 9 and all the way through. So I got the 3 pages there. If you need them, you can pause it. Otherwise, have a great day.